innovations that actually impact society and save human lives. So it's going to be a really interesting talk. Taslim, thank you so much for making time for us. And please take the stage.
Thank you. Hi again. And thanks, Maheen, for kind words. And I must, to begin with, I must say that it's a very exciting initiative, that Maheen and Devyani and Siddharth are pushing in terms of Science Cafe from the Bangalore License Cluster, because over the years we do see that the engagement of science with society in different forms is taking its a roller coaster ride, right? There have been times that the society strongly connects with science, and there has been times where that hasn't been. One thing that definitely we can see, at least in our times, that has happened, and that economic growth has led to a few things. One thing possibly that has led to, according to me, and it's my individual opinion, is that it has also resulted possibly in a lot of people actually choosing to get into professional career before they could actually achieve their higher studies, right? And that is something very, very big impact in terms of what is it. There are a lot of people who actually get into professional careers much earlier than pursue a good higher education. What has that led to is that the engagement of science has a different shapes and so on. That is one aspect from the education perspective. At the same time, there's so much going around us. Several organizations around us actually keep doing a lot of efforts. IS is not far away. I think if you saw the rankings last week, the best institution, without a doubt it is, because it has everything that one would like to have in an organization and doing a fantastic job. But how many people are as well aware about IS's efforts, RRI's efforts? It's something that we need to constantly, engage with and do that, because that will then result that science, how it conveys, it's a dialogue, it's not messaging. It should be a dialogue. A lot of people think that, okay, I want to convey what we do. That is one part of it. But then there has to be a dialogue from the other side. That, okay, what do you think of what we are doing, right? There is also an apparent, and you've heard it possibly, that people are saying that scientists should be doing this, scientists should be doing that. Possibly it is coming from different quarters of different stakeholders of the society, right? That society, possibly that is people, and then there is a governance. But that has to be a dialogue rather than conveying a message. And this attempt by the communications office on the cluster actually is a very good first step to do that. Of course, we would love to have many more people. I happen to know a couple of people already in the crowd, so that's good to start with. But I want to share today about what share, and not necessarily so that we can have, as I said, a kind of interactive session. You would know a lot of it. Some of that may be saying, okay, this I knew. The idea is that every time you share information, there could be an interaction, right? And that's what the aim is of. Good, so great to be here and thanks for coming. How do I get that going? So, can I stand here and do the work?
No, I'll do it for you.
Is that
tell you where you want me to do.
Sorry, I tried the remote where it didn't work. So, this is the campus. I think one of the very good shots. You may have been on the campus. How many have been on our campus? Wow, so that's very good. I think the rest of you should visit.
Taslim, as a matter of fact, Sujit came to our science cafes and got interested when he listened to Deepa Gash's talk, and then went on to intern at the cluster.
Fantastic.
Yeah.
Fantastic. So that's how I think the engagement has to be, right? So let's say that how many? So the rest of you should come, but it has to. Please, next slide, please. Okay, you want to take a. Okay. As you know, there are three organizations, as clearly mentioned by Maheen in the introductions. You know about NCBS, Instem, CCAM, but possibly one of our friends who do not know exactly. So NCBS is actually a center of TFR, established in early 90s, and has gone on to become possibly the best biological science research organization in India by far, and has done phenomenal job, has produced phenomenal labs and so on and so forth. It's about quality, but it's not at the scale. Instem and CCAM actually started in 2009-10 to form what we now call it as Bangalore Life Science Clusters. It has three organizations. Instem attempts to do something which is in stem cell biology largely. And it has two components. One is to understand the stem cell biology per se. It could be skin stem cell biology, it could be cancer stem cell biology, it could be neuronal stem cell biology. The second component is that regenerative medicine, right, which is to apply stem cell biology towards the application. And CCAM is a non-academic organization. When I say non-academic organization, it doesn't say it's non-research, it's non-academic. Non-academic would be, because sometimes these words are very strangely located. When I say non-academic, it's okay, you're non-academic. You don't have science going on. No, non-academic means you don't give degrees out. As simple as that. But what we intend to do, why we didn't go into, why the idea why DBT set up CCAM was to what you call it as, be a catalyst of high-end research and innovation. I'll tell you a little, some stories about that today. As in a whole, as a whole, what we wanted to do is that can we have a cluster, different flavors of scientific organizations and scientists who could possibly not only do phenomenal understanding of science or biology, what you call it as a discovery, and also have ability to convert that discovery into something that could be applied in innovation, right? And that is something very, very important. When you have different kind of people being together, it actually results into something much more productive than otherwise. Next slide, please. So discovery is an innovation, and I have a simple slide for that. If it turns out, yeah. So please tell me what is. Can someone tell me what is this about? Huh?
You mentioned of the wheel.
Sorry.
It's about that.
Yeah.
You mentioned of the wheel. So, I mean, he looks at the circle and he's like, "What the hell are we gonna do with this?" I mean, it looks useless.
More or less.
The guy
Indeed.
saying, "Meh."
Indeed. And then the other guy.
He thinks the fire is more important than the wheel.
Exactly. So those, if you want to call it discovery or a kind of an invention, the idea was that it could be that at that time somebody was cutting tree and a part of the trunk actually rolled down because of the obvious shape of the part, and say, what is happening? What do we do with that? So that's an invention per se. And then this has gone on to become one of the biggest, right, innovation that has impacted us, the mobility business. Right? But think of it where it came from all the way. The second one, and possibly in the era of Stone Age and so on, people had stones sometime to hit animals, scare them, whatever, kill them. Right? They used to have sharp stones and so on. By mistake, a spark possibly splits off, right? And what has that led to now? Absolutely, use of fire for several, right, aspects of human life. So think of it where it came from. I haven't actually gone into something what you call it as science-oriented discoveries. I said just human who have themselves actually built discoveries and what that has led to. But this is something that I possibly talk a lot about for now, I don't know for how long, but is about what has happened in terms of the huge last 60 to 70 years of our lives, not our lives, but human lives. What has happened? We all know about this, right? Penicillin. So I'm currently seeing human lives right now in the era, if you want to call it Stone Age, this age, this age. Actually, I'm right now seeing a pre-antibiotics era and then post-antibiotic era. Anybody would be able to say what is the difference between pre-antibiotics era and post-antibiotics? The biggest difference, one line.
Mortality.
Absolutely. Right? So what, if you can define that more, what is the difference in terms of impact?
Saves more lives.
Easy, and absolutely saves. So if I just expand on what Maheen has just told us, on an average, if you want to talk about in many countries, if you average it here, many countries were affected by early life deaths. The average age there was possibly around 40, 45, 50. Average age. That means that you were losing people much, much before as well. And by simple things like simple bacterial infections, the ones that we get now. The ones that we... I'm sorry?
25. Average life expectancy was 25.
Correct. Much, much before 25, then 40s and so on, exactly. This is like 1920s and like, right? And what is the current average life expectancy will be? So actually yesterday I was somewhere and somebody mentioned it's actually, so it is there, but in some countries it's already, if somebody born today, right, it is above 80. So as if today, for people who are around the age around 30, 40, 50, it's possibly 70, 75. If somebody who's born today, it's already above 80, 85. And that's the huge difference. Now talk about people from 25 to 85. And it has happened because of the entire discovery-led antibiotics innovation, right? Where, starting from Alexander Fleming, where they actually discovered the penicillin per se. And think of it, it continued. It continued till 1960s. And then after 1960s, we don't have antibiotics now. We'll come back to that. But you can see the impact of that. We know vaccines, right? What has been one of the biggest things of vaccine? We have in healthcare, I will go away from healthcare as well. Vaccines, we have seen many things, right? Like for bacterial infections, there were neonatal deaths which could not be controlled. Neonates means early few days of life, right? The baby, we were losing them. Absolutely unhealthy individual in mid-20s would die because of simple, and with antibiotics, we were able to stop that. And that's one of the things. You can think about, is a general, it doesn't look big, but look at the family. They have an absolutely fine individual, right? Be it a young kid or be it in 20s, and you have one bacterial infection which actually cannot be treated and you lose them. Think of the impact of that. And that could be prevented using such discoveries and innovations. Now, and that is something we actually are now, and I will not go into this, but something we should all discuss because it's not about all glory. We are also getting into something which means that innovation have to continue. Which means that we have not achieved the last frontier. Possibly there is no last frontier, right? What we need to do is continuously, as the nature goes there, as the challenges would come, we'll have to make sure that we have solutions to tackle those challenges. So what is the current problem with this? You all know about it, but I want to hear from you still. AMR, right? So we actually are entering into, or rather have entered into, what you call it is a pre-antibiotics era again. The entire game between infections, antibiotics, has gone through now a full circle, where there are bacterial infections. If you read Hindu mid last week, or Times of India as well, there was a very good article where there was an infection to an individual. He, if I'm not wrong, he or she possibly, but nonetheless, was admitted in a hospital. They identified which fungal strain it was, They tried all medicines for 90 days and then lost the individual. Right? In hospital, 90 days they attempted to do everything they could in one of the best hospitals. So we are actually getting into that, and that's something new innovations have to be built, and I'll talk about it a bit later. Can you go to the next slide? And this is exactly what this particular startup is trying, which is BugWorks. We all know about it. Most of you would know about it, but people, for a friend of ours who doesn't know about it, this tweet is, I'm using this slide, we have used this slide before, so don't worry about that. This slide was to share that, when Economic Times had announced the best innovation in India across sectors, 2 startups were selected and both were with us. So I'm using that for now, but no, let's forget about that. But BugWorks actually attempts to do that. So what are they attempting?
To solve this problem of which have entered into India.
Sorry?
So they're trying to solve this.
Exactly. So how would they solve it? So if you're gone into a pre-antibiotics era, you'll have to now come back to post-antibiotics era, right? So you'll have to have new antibiotics to do that. And that would require, because last proper, if I may say, gram-negative against a gram-negative bacteria, antibiotic was developed in late 50s or early 60s. And this is exactly, the challenge. So the bacteria and other microorganisms have actually grown to adopt to the conditions, right? But the antibiotics are the same. So that's one is doing. What these guys are doing, I'll possibly take on it later and then tell you more. Can you go to the next slide? Sorry, Wayne.
No problem.
So we'll be here, but I just wanted to say that these are the few examples, but there are also in agriculture, there is something a lot has happened. What is one of the biggest things that you think has happened in agriculture?
Green revolution.
The Internet of Things.
Okay, that is good, but I heard green revolution.
That's wrong.
I heard green revolution somewhere. Someone said it. Yeah, so what is it? Can you tell me more?
We just got more
Pathogen
disease resistant crops, better yield, and
Better use of technology like irrigation or
Fertilizers. Absolutely. So I'd say when we actually, let's look back from a lens of India for now, right? We can always go back, but something that is closer to us. When we got independence, late 40s, early 50s, right? We did not have capability to actually produce enough food for our population. We were negative in terms of what we had to feed to our own people, right? And because of limitations in terms of what agriculture was facing, right? We had the same amount of land. Land was not an issue. The weather, one could not change. But what was needed is that with the same weather, with the same land, with the same agriculture farmers, what technology interventions should go. So I heard that there was interventions in terms of biofertilizers or fertilizers. There were interventions in perspective of the new strains, the hybrids, the resistance, the drug resistance. Sorry, CRISPR is pretty recent. We are talking about green revolution is actually 60s, 70s, right? So you're right, and I'll come to that, and that is very important. I'll tell you, I think if you can hold on and make sure that I don't forget, the responsibility goes to you, right? So that is something that happened in agriculture, and that has led to what? Actually, in some aspects, we do know that we are surplus now. We actually export some of the food items, and it has happened because of that, right? So that is another huge impact that innovation. Anybody wants to talk about such impact like antibiotics or green revolution, any innovations, anything else in environment somebody wants to talk about?
I have a question.
Sure.
So in terms of agriculture per se, so you mentioned the green revolution right now. What are some of the innovations precisely in agriculture? Non-CCAM innovations also, as in I'm talking about like milestone innovations in agriculture, let's say over the last, since independence, and then my next question will come later about CCAM's role in that.
Sure.
Yeah, I'm just saying like, what are some of the major agricultural innovations, just to
Sure.
just
So I
for
think,
background.
as I think our friends mentioned here, the resistance in terms of stress, right? There is a stress that in agriculture you have a heat, you have water, you have salinity, right? Agriculture goes through all that. The crops go through all that. So there have been, the strains which have been developed, which are resistant, which are, if I may say developed, that means they have been screened and then brought in. We have had, the entire ability for very high production. If you actually look back at our history, a very high production of grains, largely wheat and rice. We haven't been traditionally a high-end producers of that. So there are technologies which went into develop those. A lot of our selection of hybrids, which would give much higher production, which would give much better production in terms of that. So genetics, hybrid selection in terms of the selection of the varieties of the crops, fertilizers intervention, right, and so on, and of course different technology possibly by making sure that the irrigation patterns and so on come in. So those are the ones which actually have supported at the moment. And then I want to come back to, in a way, to something that is more going to be around environment. Anybody who wants to possibly give an example of how innovation has impacted environment?
There have been bioplastics, biodegradable plastics,
Correct.
and bioethanol, alternative fuels. Yeah.
Indeed.
But then I would like to know what's even new happening, because I'm hearing bioplastics for a really long time, but I still see normal plastics. Yeah.
So I think for now, what's your name?
Kanika.
Kanika. So I think, Kanika, it's two aspects in your question or your comment. There is a behavior and there's a technology, right? So there's a behavior pattern that actually we go through, and there's a technology and how technology can go over that. But if I say so, like bioethanol you mentioned, bioplastic you mentioned, there are biofertilizers, right? When actually agriculture started, when it was about chemical pesticides.
Yes.
Now we are going towards biological pesticides,
Organic.
right? What is the difference between the two?
Because it got a harmful effect.
Indeed, it is harmful. It was harmful definitely for the infections. That's why people were spraying it. But what happened? It became harmful for the soil, the microbiota.
The beneficial species also of microbes and insects that actually help in agriculture.
That was the first thing. The second thing it actually started polluting the environment around it. The waters maybe, because it was going into waters and so on. Then, now it is all coming to us.
So disadvantages to cover advantages.
Exactly, right? So that's where the solution are coming in terms of biofertilizers, which are not necessarily chemically driven and which are safer for a broad aspects of it, which are possibly even would not be harmful for other, it could not be possibly what you want to call it as a collateral damage and so on and so forth. So coming to that, so there has been a lot of effort in terms of bioethanol, and I think of course do we understand the bioethanol concept, right? Biofuel concept. Do you think it is possible or not, and why we are not using? Anybody?
The vehicles that are right now on the street, they are not. They have not been made to. They cannot use this fuel. And the current engines that we have, they can only handle a mixture of the fuel that we use plus bioethanol or biodiesel. So you have to use it in a combination.
Correct. So in principle, yeah, please.
Another point I think is that we are not able to produce enough biofuel.
Yeah. So I'll just add to your understanding with my point. I think in labs now for years people have been able to produce bioethanol, but there is a small issue with that. Of course, you talked about the mechanism of engines are not supporting that, as we would call it. But if I may say, there is a another angle to it. The angle to it, to produce a bioethanol, if it costs you amount X, finally, it is much more than, so X per liter, if it is still much more than petrol or diesel. So for an example, you may not have it, but you may want to say that if petrol or something is X, let's say 80 rupees or whatever per liter, possibly the bioethanol is costing the economy possibly 5x. And hence,
but I also heard recently that rather having to grow biomass from which you will make bioethanol or diesel or whatever, they are also being able to use the byproducts of agriculture. So you don't have to grow something per se, but again, the byproducts also have to be large enough.
absolutely. So it's not only about source, it's about the process that you have to convert.
Correct.
And that
Yes.
process of the lab work is costing you much more per liter. So what the term that you use for that is called economics of scale. You can do it in the lab. You can actually take it and put it somewhere and see if that works. But you cannot do it at scale because the barrel cost is still possibly right now $50 to $80, right, of the oil. But the same is not true. So there is, innovations do require time. It actually has many angles before they actually come in. But let me just start from this. Like, it is a very straight thing. So C6 energy, which is not only like broadly held, they are actually still working on it. So C6 energy, what do they do? Just to help you out, they do something called ocean farming. What is ocean farming?
They grow seaweeds on structures that float on the ocean.
Okay, you know already about them.
Dustin, don't let this guy talk because he hijacks all science cafes.
Okay. So
Please switch it.
you have been blackmarked. So nonetheless, so ocean farming, so what they have been doing, which many other people are doing, it's not new about it, but what they have been able to come is a very two good stories that I want to share with you. What they have been able to come is they actually grow seaweeds. We all know about seaweeds, right? On the ocean surface. And what they are now right now is that how do we now use that seaweed and its phenomenal glycosylated molecules for use, right? So actually they started very interestingly. This is something that science and innovation is all about. Their biggest objective when they started was to produce biofuels. Were they able to do that in the lab? Yes. But as an enterprise or a startup, what they had to do is to make sure that it makes sense in the market. Otherwise, it doesn't work, right? You can have a phenomenal innovation, but it doesn't make sense. The market will not be working out. While they were doing it, because they were next to Agricultural Sciences University, GKBK, they actually figured out that within the extract of seaweed they had, when they took the extract and ran through what you call it liquid chromatography, what basically it does, it separates the extract in different fractions. So let's say you take any liquid and then you run it, it will give you a different kind of molecules or the subfractions of it. And it shows you a kind of a curve, right? And when they were looking at those liquid chromatographic curves, they actually bumped into an idea. It looked like very strongly like what do you call it? An agri growth promoter or growth enhancer, which was not possibly known before. What they did was that they took it immediately, went to Agricultural Sciences building, said that can we try this out now on lab plants and then go to agriculture. And year and a half now or 2 years now, they have actually a solution which increases the crop for at least 5 to 6, up to 5 different crops, up to 50% without doing anything. So what is that? So you are actually, if you're in the field, if you're getting 100 tons of something, you're now getting 150 tons. And that is a phenomenal thing by just actually injecting something of this nature. And that is, I would say, is a very, very important thing. And that is now been funded by Tata Capital. Mahindra and Mahindra is actually taking it to the agriculture farmers, and it is already doing this. But some more exciting of their work is the next that they have been able to do, which possibly has a potential towards something that real agricultural revolution may be there. So we all know we have viruses, right? Human viruses, we all know. But do we know that we have antiviruses as well? What medicines like antiviruses? Does anybody know what any antivirus is? So if we have a viral fever, what I wanted to say, what medicine do we take? Huh? Antiviral, right? In general, like if you have virus, you take antivirus. If you have specific viruses, you take antivirus. Right? So broadly, people are trying to do for dengue, people are trying to do that, but there are antivirals. But agriculture, where the plants have viruses, there is no antivirus. Nobody has yet found a single antivirus. So but there are pesticides which attacks the pest, but there are viruses which are a bit different, right? So there are funguses, the fungicides are there, but no virus. So what we are talking about is agriculture. Big problem of plant viruses has not been solved. A patient who had virus, and he and I both were exposed exactly to the same. But he didn't get it, and I got it. Why would that happen? Exactly, right? So because possibly I am not as strong as him in terms of my immune system, when I got exposed through my airways, through my digestive tract, somehow I could not fight it, but his immune system recognized the foreign thing, fought it out, took care of it, either by vomits, either by anything else, and so on, and he was fine and I took on. What was the difference? Immunity levels. What they are doing is the first time ever somebody has developed a plant immunity booster, right, which would allow them to be strong from together to fight against any. So it's like, a soldier who is now much more attentive to be able to fight something that comes. Please.
What is the efficacy of this compared to like a genetically modified, like virally resistant crop?
Okay, so right. So let's say from many geographies, the genetic modified crops are not allowed, right? So in India, GM crops are not allowed right now. You know about the BD brinjal, you know about possibly other things as well. While we have cotton, which is different. So when you compare in a way, if there is a particular resistant crop through any means, what it would have is efficacy is very high if it has been run through that. So let's say if there is a particular crop which has a virus resistance built in because of modification in the genome of the plant, because it could be that it would have modifications so that virus can never even get in the system, penetrate, and so on and so forth. It would be very good. This is happening. Now, can you think of this and say that, okay, this could be something exciting over the years, if not only their product, but others also start building that, right? Idea is not to talk about one that is happening around us. This is happening right here. There are several more who are attempting that. And that is one thing. Now, before I go on, I want to talk about something which is related before I come to healthcare, which I have not on the slide, which is another environmental related, right? So we all know about the several aspects of global warming, right? Policymakers and governments want to call the same as climate change. Global warming is much more strong than climate change is a simple thing. What is that? Can anybody tell me what is it? Correct. Absolutely, a lot of it, and a broad change in the ecosystem that is happening because of that. Just to help the time. Thank you for telling me the time. Yeah. So here a lot of things are happening. A lot of things
in terms of global warming, one of the biggest, if you see around, has been the production, the gases that come out, from the
Carbon dioxide.
carbon dioxide and other gases which come out, methane and so on, right? They come, which actually come out of various means. Now, if you know, even the sewages, have you walked around a sewage and felt it warm?
Yes.
All of you, who hasn't? Who hasn't? If you haven't, go. The reason is that is apparent. If you just happen to walk around, and it's not only in India, anywhere. If you walk around, you will certainly feel that there is warm, the air around that. What is that because of?
Sulfur, methane and sulfur.
Yeah. So a lot of those gases produced, right? And what is that causing? It's constantly, think of it, it's a kind of a heater, it's constantly causing that. So one of the innovations that we are actually working on through a company called String Bio, which attempts to address that. And how do they attempt to address that? They actually have the small microorganisms who eat or consume methane gas and convert into food for non-human consumption. So it's a synthetic biology approach, which actually does is that you have organisms which have likings for something like methane, right? Which can consume that, and when they consume, the byproduct that comes out is towards what we call as peptides, which can be converted to proteins, which can be converted to food, which right now, because of regulatory issues, you don't want to make it human food, but it is possible. But you actually convert into, it's because you have a lot of carbon. When you have methane, you have a lot of other aspects built into it, right? So you can use that and convert it, and that is phenomenal. And that is what is being done by a company called String Bio. Now think of it. What does it attempt? What does it actually affect? So it attempts to address what you call the global warming in some sense. At the same time, what you're converting a waste, which is affecting our world, into something called value, right? From waste to value in terms of the environmental aspect. Good. We'll go to the next one. We have Achira, which is actually very interesting. They have actually used microfluidics technology for a variety of things. It began with actually using even silk proteins to build microproteins and microfluidics and patterning for diagnostics, and they have a product in the market where you can do hormonal testing. You can actually, they were working on, if I'm not wrong, something on tuberculosis testing. They are now working on what you call it, in vitro fertilizations and so on. But completely something and trying to address something else. Can you go to the next one? Pandora is another interesting innovation in the making that somebody who is actually is excited about science innovation that you should look at. If you remember in the picture that I showed, Pandora was there. I didn't talk about it then, but they are building what you call it organs outside the body. What do you call it? Organoids. Right? What organoids is nothing where you actually try to have something which mimics organ functions but have nothing to do with the body. So they are building.
What kind of materials do they use to create?
Correct. So what did they do? The way they do it, perfectly good, is so they began with first one that it began with was liver. Right? So liver, which we all know has very important function in terms of our body, but also it has not only liver cells but many other cells. So liver cells are called hepatocytes. This is the simplest. But they use other cells as well. So liver has. So what they do is that they use actually what you call, and importantly, this is an organ is a 3D object, right? It is not a 2D, but it's a 3D. So what they do in terms of build an organ is that they understand more or less what you call it, the structure of liver in terms of how it is, and attempt to do precision printing of different kind of cells together.
So when they actually grow in the lab, they attain important properties of an organ like vascularization in terms of tissue harmonization and so on and so forth, which comes closer to what we call it as the functions of the organ.
Through cell culture,
So it is 3D cell culture. So 2D cell culture, if friends who are not in the biology and cell culture is where you actually grow cells in a petri plate, but in a 2D manner. And you have more or less you have same kind of cells which you grow and we can do it. But this is where you actually build an organ outside cell culture itself. So scaffold is one way to do that. The other way to do it is you actually program the entire thing and then build on it. So both ways are possible. So they do it from the other way around. But what they have been able to do in futuristic, so they work with one of the bigger liver transplant surgeon of Bangalore. What is the impact of this? One thing which is easy is that you can use liver organoid for testing of what you call it drugs, right? Which is a must in terms of liver toxicity studies. So you know much before you go to animals and others in terms of what's happening. More and much more reliable than when you only use cell culture. But futuristically, something that you all know, that liver, when you have liver damage, and a lot of people have liver damage because of several reasons, not only alcohol but several other reasons. What you actually do is that one has to go through the liver transplant. And it's very, very difficult to get liver transplanting. You do not have a donor, you do not have many things. So futuristically, can you actually grow from your own cells, which are adult cells, go through induced pluripotent stem cell route, have a mini organ, mini liver there, and just try to transplant it. You don't even need to have full liver transplant, you can have a patch. So you can just patch it, and now you don't need futuristically what you call it the liver donor. And that is one way which should be very, very important. But it is not today. But it has to go through, as all innovations go through, they have to go through a very rigorous process of happening there. But nothing gets, so as somebody said, your possibility is your vision, right? And unless you build a vision, you will never be able to do it. It's not possible, right? So with that vision, I have no doubt in my mind that this will be actually futuristically possible to actually take your adult somatic cells, fibroblasts and so on, and actually build through stem cell route a mini liver and then try to do it. You can actually understand, because you would have all sonography techniques, which is another science that has come out from a military thing, to understand what kind of patch you want, right? And then build on, because you know what kind of patch you want. So that's very exciting. I'll go to the next one. This is Theramit, which is, I'll not add much to Theramit, but again, they are actually one of the very exciting company which is building biologics from here. I'll go to the next one. Epigenix is another one which is building, in the interest of time I'm going a bit fast. Epigenix is building what you call it reagents for the assays, for trypsin-free assays and so on. Can you go to the next one? This is something I want to spend 1 minute more on. The Koyo Labs is another innovation that possibly is going to impact us big time, and I have no doubt about it. That's why I want to spend a couple of minutes on this. So let me give you a context of it. Has anybody heard about something called VAP, which is ventilator-associated pneumonia? Okay. Has anybody heard about a patient losing his or her life in ICU setting for infection?
I'm not
Okay. Right? A lot of deaths in fact around the world happens due to infections which are acquired in hospitals. Because hospitals are hotbed of infections, right? Like good campuses are hotbed of great ideas. Hospitals are great source of infections, no, without a doubt, right? Nobody will talk about it, but that's truth. Because there are people who go to get treated, the hospitals have to be even better in terms of making sure that that doesn't transmit to others and so on. What happens here
is when a patient, we all know about ventilators, right? We know all about ventilators. What happens, patient is on ventilator, he or she has a tube, right, which is with them. Now, when I speak right now, when I talk to you, when I speak to you, what is happening? I'm getting saliva, I'm getting oral secretions. What is happening to that?
It's forming air.
Hmm?
Dispersing.
Sorry?
It's dispersing in the air for example.
No, my
Saliva goes to your stomach. You
correct,
take it.
correct. And it is also exposed. So I am exposed as well as saliva goes inside my stomach. Now, at the same, so let's say somebody who is now, and there is some involuntary, voluntary action. I know that it is going to stomach when I want to, but sometimes it goes when I know, but I do not know. Right? So now the idea is that when a patient is on ventilator, their saliva also is happening, right? Because of whatever reasons now. The glands are secreting saliva and so on. But at the same time, as you rightly said, there are people who, and the exposures in terms of airborne pathogens are there, right? Now think of it, those airborne pathogens, you can clean the equipment, you can change the bed sheet, but there are airborne pathogens which are floating around. They get exposed to saliva. And when it's supposed to go, when I speak right now, if let's say there are bacteria around, I open my mouth, right? I'm actually breathing in as well as eating in, if I may say, or you know, if there is, this environment has definitely some load of microorganisms which I'm actually taking in, right or not? Now think of, but what I'm doing is doing this. Now what happens in those patients, and that is a very crucial thing, those patients actually, instead of putting into your gut, stomach, it actually goes to their lungs, because you can still breathe through your mouth. You can, right? So your mouth actually has two tracks openings. One is a gut, and one is a airway. They happen actually, in some reasons, they actually happen because of ventilator, there is no involuntary action. It happened to go to the lungs, immediately causing what you call it as a ventilator-associated pneumonia. And due to the numbers that have been put up in terms of statistics about what is the mortality or deaths out of that, guess how many percentage will get some VAP? More or less, exactly that. People say that if one gets VAP in a bit older age, 50% chance you'll never come back.
So sorry, it's VAP, is it? VAP?
VAP. You can do VABP as well, ventilator-associated pneumonia. You can call it ventilator-associated bacterial pneumonia or ventilator-associated viral pneumonia or something like that. But think of it, 50% chances of that. So what Koyo labs have done, who are actually building something very smart. So along with what you call it tube, they have actually added one more tubing of this size, which goes to your trachea and has the sense of a humidity or moisture. As soon as it is formed, what do? They just aspirate it out and bleach it right there. Do a quick mouthwash, and then we aspirate it out again. So what are they doing? They're actually not allowing the infected saliva to go anywhere. It's just coming out, it is not going in. And that is a huge prevention in terms of VAP. Now they have done a small study of 14 people, and none of them got VAP. None of them got VAP. And that's a huge, huge thing. And this is a global thing. This is not only happening in Bangalore, this is also happening in Boston, Harvard. This is happening in London. This is happening in all big hospitals. This is not related to a particular geography and how advanced the healthcare system is across. And this innovation has the potential to prevent VAP happening and save humongous number of human lives. And that is, we are very, very excited about that.
I have a question
Sure.
to this, because tubes are used in the ventilator, that's where this question is coming from there. So I have heard of catheter infections wherein bacteria form biofilms.
Correct.
So are they doing something, do they also work on something like this, or the innovation that they mentioned is dealing with this also?
Yeah, no. So the work that they have done, as you know, is not even touching anything. They don't know what, they don't know bacteria, they don't know, think of it, they don't know viruses. What they know is that I don't want that saliva to go down. I don't want that mucus secretion to go down. They don't know whether it could be infection or no, I will take it out. So they are a very design oriented. So they are actually designers who have come together. Nobody knows biology there. But what they did is they actually spent time in hospitals and saying, why is it happening? Nurses are going every 10 minutes to do that manually. But think of it, can nurses be there full time? Would still be saliva going down and still the deaths are happening. And it's happening very rapidly. So they are not there, but they are not solving the catheter-based infections. But there are people who are doing it, and I'll tell you the example of people who have the catheters. You have several catheters which are being used. What happens is that they are there for a long amount of time inside the body, which slowly causes the biofilm formation, and then that causes further issues. So what people are doing is that on catheters they are now putting molecules which will not allow to form biofilms. So people are working on it. There are already catheters which are coming. So the surface of the catheter, which is being manufactured by the companies, they would have the molecules which will not allow the biofilm formation to begin with, and hence prevent it. There are people who are doing it.
So this device senses the mucus and then it blocks the mucus.
Yeah, it's it's kind of a sensing moisture, humidity, which is from a mucus as a thing, and then aspirate it out. Just like you go to your dentist, right? It's almost that. When you go to dentist, you have an aspiration thing, is there, but it is not sensing. It is almost there, and then just constantly aspirating out.
It's similar to a suction.
It's suction too, but used very smartly where it was needed, right?
Doesn't bacteria have its own basal mucosiliary type of thing, in which there's already some moisture that's in circulation?
So exactly, so it is not that high, right? Idea is that what is the difference that you're doing? So you want to prevent as much as is going on, which is coming from the external. Shall we go to the next one? I think we have gone 1 hour now, so I'll try to keep it slow. I talked about Achira, we know about it. We'll go to the next one. This is the team that you're doing it. Now, this is also very interesting work that happened from IIT Madras. A lot of people in healthcare using now lasers. Do you know lasers for ablation? Just for friends who are not on top of it, because they may have a different training, other trainings. Lasers for ablation of tissue. Cancer. A lot of people, instead of going and cutting it, they are using lasers to just ablate the tissue. And kill the tissue using the laser, hard laser. Now what is happening there is that but there is a problem with that. What could be the problem? Anybody?
Exposing others.
Exposing others, yeah. Precision, almost the thing, right? Same thing, collateral damage. Why? Because let's say if I want to hit a particular tissue and organ, but everything is not directly exposed, right? So I have to go through some way. If I'm using any way of getting inside the body, right? It is still, I have to turn around and all. A lot of lasers actually do. So right now, what idea is that, so if you are hitting a particular organ, which is not intended to be as a collateral, that also will have an impact. What these guys do is actually build indigenous lasers. Now physics impacting this. Indigenous lasers which would only be specific for that organs. So they would have the frequency or wavelength which would only work for that particular thing and won't impact the other tissues. So it's a very specific to specific organs in a way. We'll go to the next one. So you can use in urology, because a lot of urology ablations are done in dermatology and so on and so forth. These guys are also doing very smart thing, you can say, for liver biopsy, right? So for biopsy is used for what, anyone?
Checking the
Yeah, exactly. Right. So you want to understand what's wrong with the tissue. So you have to take a piece of it, go under the microscope more or less, right, and see what's wrong. Now, what they do is that for liver biopsy, what you traditionally have to do is an internal organ, right? So you cannot use the sonography to understand what exactly is wrong if it's not visible. So you have to have a part of it to do a pathological study. You cannot have a sonography-based study, so you cannot have a radiation-based study. So you have to cut it, take a part of it and come back. They have built a small device which is nothing like a small gun. Under the sonography, you position it. I'm going fast in terms because of the time issue. They do a shot. It's almost like a small syringe injection. It goes there, precision, take a small piece which is right here, and then come back. It's almost like the injection that you have done. And you can actually be out. So it's minimum invasive, the biopsy that you do. And now they are building biopsies for several other internal organs, including semi-solid organs. And that's a very, very smart engineering they have been able to do. This work is from
Can I
us.
ask a related question? The biopsy of skin is such a difficult process even now. And is there anything for that like this?
So can you tell me a little bit more about the why?
Biopsy of skin.
Like what?
The procedure that they do is it takes an hour of time. They take the skin part, 1 centimeter of the skin, and then do it.
So they do it differently. Possibly I'm not on top of it. I'm happy to. But the ones that I knew, they would actually do a puncture, a small pinch. So it would be very quick. It will it will hurt a little bit, but to do a pick and then it comes back. You don't have to do bigger based on what you're looking for. But I am not on top of it big time, so I will not be able to claim that I know it. So this one again allows you to do point of care, what you call it, quantitative malaria diagnostics. What does it mean? This guy, ISC professor, has actually built something where you have a simple small microfluidic device, let the blood go in with some staining, and then you take an image, simple image, analyze the image. So this is a microfluidics. You take an image. What happens very smart, when you actually your blood cells are actually infected, your intracellular, within the cell, intracellular structure or morphology is distinct from if you're not infected in case of the plasmodium one. With simple intracellular morphology oriented staining, you can actually say how many cells are infected, and you can do quantitative analysis of the parasite infection per se. Very, very smart way to do that things going forward. Another very smart thing, I think it hasn't gone as far, but very interesting idea. Innovations are all about do you know one of the biggest problem in TB? Multi-drug resistance. And one of the reasons that comes, because there are many reasons, is the compliance. What happens is that TB, you know that it's 4 months schedule of medicines, right? But what happens? A lot of people actually have the symptoms of TB. They go to doctor, the doctor gives medicines, which is for 4 months. The person takes it. After some time, I don't know whether it's 15 days or a month or a month and a half, the person feels better. Now think about it from your own lazy mind. What will we do when we feel better?
You stop taking.
That's 90% of the case. 90% of people actually stop taking it when they feel better, when they're not coughing anymore. But why is it 4 months? There must be a reason for 4 months. To get rid of them completely, it takes that much time, right? So what you have done, you have gone to a battle and you thought that everyone is dead and you have come back. Right? That's exactly what's happening here. But you had to go in, finish everything and then come back. So you've gone and then some guys were half dead, but they're still not dead and you come back. Now they could come back. And that's one of the reasons now. But when they come back, they know your tricks, they know your techniques. And they come back stronger. And that's what one of the reasons for what they have done, and now people globally are working on, including MIT and so on, have a skin-based delivery, which will be an automated drug delivery to be able to do that. That's another way to do it. I think Pendulum we have spoken about. I'm coming to very close to an end, so hopefully I'll be next year. this is, we have spoken about the agriculture, but another agriculture point that I want to say, since we have spoken about the next one, is something from our campus, and INSTEM faculty who's actually working on a very interesting thing, and the product may come to market very soon, is about, look at this Hindu article, and if I can help you read it. Pesticides cause farmer deaths, illness in Yavatmal. This is in Maharashtra. If you read this, and I happened to read it a year and a half myself when we took this picture, actually it's a very comprehensive analysis of how much pesticides actually is damaging not only deaths, which are easily visible, but a lot of farmers actually take on serious health issues and organ failures because of constant exposure. So what they do, as you can clearly see, they have, what is the bottom line for them? They have to protect their crop. One way to protect is pesticides. So they go on and keep on doing this pesticide business. And when they do it, it's a hot summer, right? So they go, they have possibly half pant, some shirt, and constant. So when the spraying is happening, it's not a unidirectional, it's a broad. And look at this. Where is this going to come back? He or she is the one who is following that thing, right? It's constantly being exposed, and leads to real issues. And so what Praveen, who is INSTEM faculty and CCAM innovator, was actually built is something, what you call it, a gel, which would be, a topical gel. And even if it falls on the body of the person who is actually spraying it, chemically, the gel would break the pesticide as when it falls on it in some time or other. What does that mean? That the pesticide would not be able to penetrate because it's broken down. So it's ineffective in terms of its toxicity further. And that is something very, very exciting what he has done, and it will be very, very useful. Unfortunately, I don't have the picture of its product. We have seen, this is more or less my last slide, and I want this, there's nothing on this slide, so don't wait for that. But what we have seen in last few minutes or an hour is that there's a lot happening. When we look back in terms of 100 years, 200 years, or the ones thousands of years ago, there have been discoveries, accidental understandings, knowledge, and so on, which have impacted us a long time. And we, in this era, when we do innovate, it would not only have a short-term impact on our lives, but long-term impact on our lives, right? The discovery of vaccines was for the one, or you did not remind me about the CRISPR for that sake. It would have a phenomenal way to actually do that. The way people are doing CRISPR, just to help on that conversation, is that a possible way to use CRISPR to do, I'll not go into technicalities of that, to do gene editing, which would be very, very useful for a lot of diseases, agriculture, and even environment going forward and so on. A safe gene editing aspect. So what are the aspects we have seen? We have human lives which are impacted through healthcare, human lives which are impacted through agriculture, and human lives which are impacted through environment. A lot of these innovations enable us to work in that, right? Please. Yes, that's the one.
That's the gel. If you just look it up on Google, you'll be able to find it. And there are loads of journalistic articles that have been written and published across various newspapers. No, it's made in collaboration with INSTEM.
So it's a startup which is now being formed called Sapio. As Mahin said, this has been through an INSTEM scientist who became an CCAM innovator as well. And now it has been converted into a startup called Sapio, which will bring the product out. I could be wrong in the name, but I'll correct it if it's wrong. Okay. But what I was trying to say, thanks Mahin for sharing the picture. But what I was saying is that there is a lot that is going on. Some of the examples are some that I knew deeply enough to share, but there's a lot going on, not only in Bangalore, but there's a lot going on other parts of the country and there's other parts of the world as well. But what is very, very important is that when we talk about this science and innovations, is to engage now as a follow-up with those innovators and say what is going on. If Koyo Labs guys had not been in hospitals for 6 months and seen what's going on, right? They would not have seen that there is some, just for a simple reason, we are losing lives, and come up with a very smart way of putting a suction device and do that. But nobody thought about it. They actually were ranked as top 50 technology in the world by Marsden Hospital. And that is very, very important. So innovations are nothing but looking at a problem and taking your knowledge, be it in science or engineering or any other field, and address the problem. Right? So I definitely urge you guys to come by. If you have any other question, let us know and visit us sometime through, of course, the communications team, and we can chat more. We may have this more often through other innovators who will come and talk about. But if you just want to talk about what's happening, if you see the problem, we have something called Agri Innovation Center now at CCAM, where we are looking for problems rather than the solutions. We want to know the problems, and we think that we would have enough wherewithal to actually build solutions for that. The other thing that we are doing is something called Geriatrics Innovation Center, where we are looking to actually identify the problems in geriatrics. Geriatrics is nothing but science of old age. But let's say old age people, they go through a lot of issues which are not known. The old age people, you can only think about, oh, they cannot walk properly, so they will need something. Oh, they have to go to the bathroom, they fall in the bathroom, right? And they forget dementia and so on. But there are so many other things in their life they actually completely not detected. So if you have those things, we're very happy to do that. Actually, I don't know, there is a call open that reminds me from under our Agri Innovation Center for somebody who wants to go in any spectrum of agriculture sector and find problems for us. It is a paid fellowship, which we call it Agri Innovation Fellow, to identify the problems which are previously identified. So that is also open. So feel free to spread the word. It was great to be here, and these are the coordinates that we use normally. Thank you.
We will have a question answer.
Sure,
If,
absolutely.
In case you haven't eaten enough of Taslim's brains, please continue to eat some more.
And if you're hungry, you can also go downstairs, have snacks, and still informally chat with him if you want, over snacks.
So, are there startups working on computational drug design?
Yes, very much. Significant. So, AI, which we didn't talk about, I'm happy to talk about AI for an hour, but AI is actually coming big way. Computational first was the computation, but now AI is coming in terms of helping people to do drug design so that you don't fail through the otherwise the way drugs fall, and the overall drug development becomes so expensive, right? Why do we have drugs so costly while actually its manufacturing is not costly? Because of the development costs. So now AI is coming big time in terms of helping to go through the entire process to make sure to, take away or weed away, if I may say so, the possibilities of doing that. So it's heavily used, heavily. Yeah, please.
On one of your slides, you spoke about the lasers, some organ-specific wavelengths. Can you talk about a little about that?
So exactly. So what is happening is that every tissue has a different response, because every tissue is made up of different material, right? So liver has a different thing compared to heart.
The wavelength?
No, the tissue, the response that if I shine light on it, because it's a two different material, right? So if I, sorry? Correct. So those are there, and what they make finally as an organ, they are not similar. They would have different response to anything that you shine on, right? So you understand that which tissues actually get affected by which wavelengths in a way. How do they respond to it? So what you have understanding is that different organs and their responses in terms of the harm, in terms of the refract, and so on and so forth.
So you can use that to ablate?
Yes, specific only. So the other one, so let's say here, it's like this, that out of 10, if I use a wavelength of, possibly, let's say, very high laser in the UV range, around 350 or something, it may not be damaging A organ, but may be damaging B organ. Right? And that's what I try to choose. But right now people are just using anything, it's strong enough to kill that. So instead of, if I may want to call it, this is very similar to broad spectrum antibiotics to specific antibiotics. It's nothing but that. Very strange correlation, but it's exactly this. Broad spectrum antibiotics would kill everything. It's a big hammer for a small nail. And specific antibiotic would only kill the viruses that you want to kill. Specific virus.
Why are you pointing at her?
Because she asked this question about the virus.
The little hammer.
No, the question was about the specific virus.
Yeah.
So it was that specific. So it's about the specificity to decrease the collateral damage. Yeah.
So you spoke about the specificity with respect to a different organ. But what if I say कि only inside a liver, a specific part is having cancerous cells and the rest are not? So then can the laser differentiate between the cancerous tissue and the healthy tissue within the same organ?
Absolutely good question. Absolutely good question. And people are working on it. People are working on it in multiple ways. So right now, one of the interesting things that people want to do is that to understand within your cells to see if cancerous cells have different properties than your normal cells.
Yes, they do, and also at the antigenic level. But that's what I want to know, that can the laser differentiate that? Because clearly there is no demarcation if you just look at the tissue. There is not.
Exactly.
Physically.
You're spot on. So what I'm intending to say is that right now people are working out to say whether the same cell and some cells have become what you call it cancerous. Now because of cancerous, not only because of antigenic, so molecular, but does it also have some now different physical or mechanical properties, right? So there are people who are working on that I know of, that actually metastatic cells have much more rigid biomembranes than otherwise, right? There are other aspects as well. So one is to identify and lock in the difference, clear differentiator, be it in terms of antigenic properties, physical properties, biomechanical properties of cell. And once you do that, that's the understanding, you can apply aspects to it and say that, the change of 10 or 20 nanometers may give me the differentiator. How will it be useful? It will be useful big time, I'll tell you, when you're actually trying to do a small surgery, where you want to take out the cancerous part. So you can just shine it, and only that part would reflect, rather. So you would not take more of a good organ, and you only remove that. That's a big problem in cancer surgery right now, as you all know, that people end up, they try best to make sure that they mark the surgery to be there, but still, to prevent the recurrence, they take more, so that there's nothing left out. So if you shine something, let's look at this very good. They have a pen, they go with a scalpel, have the laser pen, shine it, cut it, they are sure about it because it has different properties, and you do that. But that's what the future, that's what technology will enable us to do. Please.
Is there a way to validate is there a platform where you can validate data ideas validated?
Can you go inside?
Is there a platform where you can get your ideas validated? So for example, if you have a problem that affects like a significant portion of the population, but to approach that, there can be many solutions.
Correct. Of course.
Is there a way we can get our ideas validated?
In terms of technical validation?
Yeah, and in terms of how, if it's a good idea.
So I would say this way, if it's a good idea, so I would say that we have small, what you call it as immersion innovation programs. If you do have it, please reach out to me. My email ID I gave, it's rather here, taslim@ccam.rs.in. the bandwidth doesn't allow, but I'll be very happy if this group wants to do something, and there are enough people who are proactive. We'll be very happy to have a small program to discuss those ideas and take it forward. But some of you will have to be proactive to, be on the same wavelength of dialogue. Otherwise, what will happen? People will drift away because of the other things. But in terms of even technical validation, we may have resources to support you through something and good ideas as well. Does that answer your question?
No, so for example, do you absolutely need to have some sort of preliminary data?
You don't. So there are funding programs where we fund with just your idea. Your idea which is not even written down, we are happy to discuss that.
Wow.
Okay? Please go first. She goes.
So a lot of the ideas,
She was before you. Sorry.
a lot of the ideas that are discussed are very healthcare focused. I was wondering if there are agri-food related projects that are, or innovators that are currently working at CCAM, like for instance, something like alternate protein-based foods or something of that sort, like plant-based or cell-based foods. So I was wondering, because it's too close to UAS as well, I was wondering if there are collaborative projects in this field.
Absolutely. No, thanks for the question. So a couple of agri clearly I mentioned out of 8 or something healthcare, I mentioned 2 agri. One is C6 energy, which is, and the other one is the CEPIO, the work from Praveen Vemula, was for farmers in a way, for agriculture. But if I may want to add in terms of the, the food, one of the food one that is somebody like Espartica, which just won a national PwC power, what is it, Cooper? Right, correct, no? PricewaterhouseCoopers, I haven't said that for a long time, I just lost it. So PricewaterhouseCoopers started a program called Level Next to select the best 6 or 7 companies across India to scale up. So one of our startups actually won it called Espartica, which is actually using something very interesting, and that is also an environmental thing. I didn't get to talk about all. What they do is, do you know there's a huge silkworm industry right next to us? Where? Kanakpura, right? Silkwood is there, Kanakpura is there. All entire side, if you go further, there's entire silkwood industry, right? What happens there? Okay, in silkwood, what will happen is that you have silkworms which produce silk, which is used for further, right? Now, but there is waste related to silkworm industry. What is that? Huge waste. Absolutely, right? Huge waste. Where do they go? They are being dumped, right? Although they are biological, they are being dumped, but it's a main problem. There are kilos and kilos and kilos, and they just dump somewhere. It can cause biological waste while it is biocompatible. What is the problem with that?
So I think I thought that in a big grant, earlier there was a student from agriculture university. They have an entrepreneurship from that protein.
Correct. So absolutely. So if I may add, if you have biological waste, what can happen is that you have germs and infections coming out of that because you have biological things happening, right? If you have plastic, you do not have anything to grow the bacteria on, or the fungus on, the viruses on. But if biological waste, that's what you're going to cause. You can put a lot of biological waste, and what's going to happen? Well, it's compatible and degrade, it can also cause that. So what that person, Espartica, has done is that to take that, go to that industry, take the waste out, understood what would be the best, and what they have figured out is that it has something called omega-3 fatty acids, if you have heard about it, right? Where do the omega-3 fatty acids usually come from? Cod liver oil or something, right? And it is supposed to be very good. Now, according to him, the work that he has done, he has actually figured out that it has 6 times more concentrated omega-3 fatty acid, the cocoons, based on the process that he has used compared to the cod liver oil. And that is phenomenal. So that now he is putting it as a product out for several consumptions, be it for poultry or something else. Now from waste to food in a way value. So that is one. Now another person that is working from agriculture is working on something that's a very big problem in something called pomegranate. If you talk to agriculture farmers, they have a huge issue in terms of infections, and it's called Xanthomonas infections. So that particular person called Mahesh has actually identified new strains which work against, bacterial strains which work against Xanthomonas. So it would be kind of a biofertilizer or a biopesticide which when applied will work against Xanthomonas and protect the pomegranate crop against those things. And there are a few more which I can keep sharing, but there are ones which are doing it. And the Agri Innovation Center is direct attempt to actually do more and more in agriculture. The reasons we actually ended up deciding that we'll do in agriculture was real one observation that we actually realized after many years. Healthcare is something that we talk about majorly. So innovators are addressing that, but agriculture is not spoken as much. So the problems in agriculture are not as visible, are not well articulated. And that's why I said we are looking for problems in agriculture so that we could have wherewithal to answer it. What is there in agriculture and geriatrics? Problems are absolutely invisible. Yes, professors know about it, but that's it. The innovators who are not domain specific do not know about it. That's why we have started Agri Innovation Center. That has been supported by Government of Karnataka. You had a question. Can I go again? Because I had given this.
So actually, I finished my graduation in GK 20. So I applied for Agri Immersion program. So you were talking about we have a program to identify problems in the pharmacy. That is that related to Agri Immersion or
Can you come again?
Agri Immersion, I think.
Yeah, it's Agri Immersion is under Agri Innovation Center.
Yeah, I applied for that.
Okay.
And I have an idea also regarding the soil testing equipment development.
Okay.
It's supported.
Absolutely.
So I applied for that, and what is the process and how it is?
I won't be able to tell you now. There's a team working on it, but if I may say so, the call is open. That's why I said the call is open. What will happen is that we already have got a very high response to that. So we will pick a few and then we will call you to come and present about what your thoughts are in terms of if you were to spend 6 months in the agriculture sector, it could be Krishi Vigyan Kendras, it could be in the farmland somewhere, it could be somewhere else. How would you do that? And learn about your ways to say, how would you explore the way Koyo Labs guys stayed in hospitals looking for problems and realized there was a problem. We want that thought process to be done here. Immersion is for that. So we will be in touch. Yeah, thanks.
So as and when more products get developed and commercialized, like there is a need to have a regulatory framework.
Alright.
And especially with countries like China, where I've been reading like very scary things of CRISPR being used to augment IQs and stuff like that. So how are the policymakers looking at those things? That's one question. The second thing is like one more thing with respect to bio-entrepreneurship. What I observed from the West is that young kids sort of collaborate with universities and get into it. They also have specific fellowships for the same, like field fellowships or it. So, can India also do the same, or what is it required to do?
Okay, I'll take those two questions in the same order. The first question was about the regulations of those, right? Of course, those have to be regulated. There is an issue of ethics, right? And then there is regulations. So one has to have an ethics policy first, and based on the ethics policy, one has to regulate it. You have to know why are you regulating and what you are regulating. And then the regulatory policy may come down. Now, and that has to happen everywhere. So I think that's a level of so GM crops are still regulated in India. If I were the one, I would individually think that, you have to have actually a much more layered policy rather than a one-stop policy. What we have done is that we have actually had a knee-jerk reaction to GM. Right? There might be GM which are bad, there might be GM which are good. And we have to actually sit down and understand what is good, what is bad, and have a differentiating policy than not. I think similarly, CRISPR could have a differentiating policy in terms of what is good and what is not, and have them control. But that dialogue actually again happens to us. How many of you know that any government, whenever they build a policy, the draft comes online? And how many of us will actually reply to that? not many know. It is not very visible. But people have to be proactive. We cannot say that it's bad, right? We may want to be proactive if we are worried about this. So we should look out for that. There's an AI draft online. There is something else online. So anything that comes in and they frame a policy, the draft actually gets online for response from people. So they are done saying that I have put it somewhere because I can't call everyone, I can't mail everyone. So the one way I have to do it, I have to put it on a platform that is accessible and not restricted to anybody and do that. So look out for those things. It doesn't need to be central. It could be even local, right? It could be even state level, even city level. So look out for those things and participate in that. And that's the best way to make a contribution in terms of policy making. I know it's not that easy, but the more we do it, it will become more effective.
So
if we don't do it, it will not be effective.
Think tanks.
Think tanks are all actually makes the draft.
Yeah.
The experts make the draft because they do not want to have the ideas first. They want to give you something that they have built on, and then they want a response on that. So think tank and experts and all that, they work heavily, come back with something that you can now comment on as a general public, and that is something we should be responding to more. Yeah.
So you spoke about this company which releases bacteria that consume methane into sewage and so all of these companies, where do they get their revenue from? Like when you make a product, you sell it and then you get revenue. What do these? Yes, essentially.
So revenue is, let's say if you want to say revenue, so idea is that for that company only, the revenue futuristically would be to able to do two. So they can do two ways. Revenue could come from the products they are making, that is the protein or the some generating a revenue. Yeah.
I think maybe we could take further questions along with the snacks. I think it's already 12:30.
If there is any specific question before we...
Any other pressing questions that have to be asked?
Go ahead if you want. So, I think that would be the last question.
Yeah.
For now.
I mean, you can still ask him questions during the snacks.
Everyone's going to be...
Yeah, sure. No, but go ahead.
Yeah, so, with just a continuation of the regulated question. So, in terms of new innovations in general, say, healthcare or others, we as India largely lack in terms of regulatory compliance and in terms of framework establishment itself. So, while I agree that America and other things do have some amount of regulation, there also lacks in terms of new innovation. What do we as like university students or like working professionals really have to identify in order to ensure that we can create a regulatory framework or buy into a regulatory framework? What kind of solutions can we offer to change regulatory framework as such? Because more often than not, like these think tanks make blanket policies or like blanket assertions of what the framework is supposed to be compared to what our input can be in terms of frameworks.
And also, like for moving it, like it's a, I mean, you know, it has to move through a legislation. There's so much. I mean, the process is so complicated. So
I completely agree with you. What we need to do is constantly make our point, right? To make a legislation, you have to go through MPs, right? And what you could do is that, of course, it is not easy. So it is very easy to say, but I think we could still fancy to actually do the way where we can engage with locally and saying we are putting our case and a note to the MP. And then say that, okay, when you're talking to MP, let's give it to a Karnataka MPs for now. In Karnataka MPs, let's say we're talking to Bellanur, right? Can we take Karnataka MPs, at least 10 of them, have them agree to do something and have that go to the parliament, right? But that's the only way to do that. After it has been passed. But something that has not been passed is still online. So while they do mean possibly blanket statements, knee-jerk reactions and so on, that's one draft. It is never done in a day or overnight, largely, unless it is a very mail thing. So there is a time that has actually been done, and there is actually a vacuum, if I may say so, in terms of our societal structure right now to engage with that. We don't engage with that aspect of the governance as much. We have lost that. We have rather been stricken, the politics has more, or engaging with government has more become what they want us to talk about. They want us to talk about something completely crazy stuff that we all know about. But They don't want to talk about us because that becomes easier for them. They distract us from the main things and do that. But we have to do that, and we have to constantly do that. And that is a vacuum, and I don't know what is the answer, but there is no alternate to engage on that when the draft comes out. Can we make it public? Can we spread it? The social media is strong now. Can we say, okay, by the way, people who are concerned about this, please do look at it. Can we make a small forum to do it and then send it, and we can then tag people who do matter. I'm sure there are people who are doing it. The current principal scientific advisor is phenomenally accessible, right? We can always share things with them. There are other people who are phenomenally accessible, and social media allows that to do. The only thing we have to do is that spot that opportunity that now draft is open. Do a little bit of homework, identify what we want to say, and say this has been drafted, and go there. There is no system right now to do that. Perhaps there could be a system to do it among us, or there could be still an organic way of doing it. Not sure about that. But I can say it is not very strong. And I think people who are concerned about all this, we should be proactively trying to do a structure about it. We should do that.
Just a small follow-up.
Please.
Are there organizations which specifically target advocacy for these sort of legislations, or white papers, etc.?
Actually, they do. Interestingly, you have to spot them. So I just got yesterday a note from Carnegie.
Yeah, Carnegie.
Yesterday I got a note from them, Rudra, where I'm helping them on a few things about that. You have to just engage with them, right? They do a phenomenal, like I did a 1 hour or 2 hours in current Bangalore Summit, they call it, right? No, there's some innovation summit or something they call it. So I've had that. So they are in the policy, decision lobbying, and they do want to pick those. We have to just flop onto them and use that to do further. They will be very happy to do that because they do want to share that. There might be other as well, but there is a vacuum. When I say vacuum, it is actually in terms of the scale, it is vacuum because there are not enough players, and we may want to just come and do that. The way I think we are building more and more in science communications, not many people were talking about science long back. We have to do something like this here as well. Good. Thank you so much, guys. It was fun to share things. Thank you so much.
All right. Can we all thank Taslim for the wonderful talk? Just another.
People who organized this, I think, if you don't mind.
Just a small request, as you're going out, if any of you have come in late and have not registered, could you please leave your contact details so we can contact you about further Science Cafe details? Yeah, there's a laptop with a Google form, it's a very short form. Just fill it in as you're walking downstairs.
Just stay on for 30 seconds. I have something to say. How many have you been here before at HSP? Anyone?